12.7 Quadric Surfaces Part 3. We're going to look at cylinders. Here are three cylinders. X squared plus y squared equals 1 is parallel to the z-axis. X squared plus z squared equals 1 parallel to the y-axis. You'll notice it's parallel to the missing variable. Let's have a look at one of these at random. How about if we do y squared plus z squared equals 1. And I'll show you how to think of the graph. Okay, first of all, in the YZ plane, you can plot a circle. It's just a circle of radius 1. Pretty simple. This would be 1, this would be 1. And then what we could do is, it's implied here, y squared plus z squared equals 1. X can be anything. There's no x here, but x can be 5, x can be 10, x can be pi squared, whatever. What we're going to do is move down the x-axis. Let's suppose x equals 5. This could be 5, for instance. And then we're just going to make another circle. The same size. Well, that's a little too big, but you can pretend it's the same size. And then we will connect the dots. You can make this a dotted line because it would be hidden. And that's our cylinder. It's parallel to the x-axis. X is missing. Well, this is what's called a right circular cylinder. There are other cylinders. Let's suppose we have z equals sine x. Believe it or not, that's a cylinder that's also called an open cylinder. Anytime you have a curve with a missing variable, it defines a mathematical quantity called a cylinder. So there's y, there's z, there's x. Z equals sine x. What I'm going to do is I'll graph a sine wave. That would be 2 pi. Guess what? It's parallel to the y-axis, right? So I can move down here. And same thing. And we can connect the dots. And that gives us a three-dimensional sine curve. And that also is a cylinder. It's an open cylinder because it's an open generating curve. It doesn't close on itself. Wouldn't be fairly useful for using, if we're interested in building a cylindrical pipe to make a slurry line or something like that. Not very useful to use this generating curve. It wouldn't be very productive. But it is, from a mathematician standpoint, a cylinder. So. Okay, that's all there is to cylinders.